Hello everyone. What we'd like to do in this next set of videos, which will be really the last bulk of material that we cover in this class, is we're going to be studying these things called conic sections, these special shapes. And I'll explain why they get their name conic sections near the end of this set of videos. So what we're going to be doing is we're going to be thinking about shapes. Some of them will be familiar to you, but we're going to think about them in a more geometrical context. We're going to be defining shapes from lines, dots, fixed distances, sums of differences, differences of distances. We're going to explore a whole bunch of different ideas. Let's go ahead and get started with our first conic. Okay, so our first conic, I'll write it as conic number 1. Conic number 1. Okay? Let's say that we have a dot. I don't know, we have some sort of dot here. And we want to think about what kind of shapes we could create with this dot. Well, a natural shape that we could think about defining is thinking about the set of points that have a fixed distance from this point. Let's write that up. This is going to be our first shape, kind of a geometrical definition, is we want to find all the points. So the set of all points that are a fixed distance from a point. Okay, so let's think about what this shape here would be. You might already have a good idea of what shape we're going to draw here. So what I have here is I have a marker and I have a string. So this will be our fixed length. And what I'm going to do is I'm going to take this string and I'm going to tape it here to the board. So we have this marker now has a fixed distance. It's a fixed distance from the center. So let's go ahead and draw the entire set of points that are a fixed distance from the center. So all of these points here. Here we go. Here are the set of all points that are a fixed distance from this center here. What shape do we get here? What geometric shape did we describe? We described a circle. So what I've written on the board, this is the geometrical definition of a circle. So conic number 1, what is it? Down, down, down. The circle. The circle. Beautiful. This will be the simplest of the conics that we study. And now that we know a nice geometrical definition of a circle, let's label some of its parts. Okay, so here we say the set of all points that are a fixed distance from a point. Now this word, the fixed distance from a point, we call this point here the center of the circle. Okay, so this here is the center. And we have a fixed distance, so from here to here, we have some sort of fixed distance on this circle. This fixed distance, maybe I'll do this in green, this fixed distance has a special name. It's called the radius. We call this the radius of the circle. Okay, so this here is going to be R. We'll rotate it with we'll use the letter R, and this is the radius. Now, what our job is going to be from now, or what we're going to do next, really with all our conics, once we have a geometric definition and we discover what shape it is, what we want to do is we want to try to find an equation for this shape. Can we come up with a formula that describes the entire set of points that are a fixed distance from the center? Okay, well, let's try and do this. So right now, for convenience, just for convenience of measurement, let's assume that the center is at the origin. So for right now, let's say that the center is at the point 0, 0. We'll move it later. So, and let's make an XY grid here. Okay, so here we have the XY plane. So this is X. And this is Y. And so what we're going to do is we're going to think about a general point that is on our shape here. Okay. Let's say the point on our shape has coordinates x and y. Okay, what must be true about x and y if they are on this circle? Well, what we know about x and y is that if we were to measure the distance from this point x and y to the center, it would always be a distance of r. We could use the distance formula, or we could just draw ourselves a nice right triangle. So what's great here is we have this beautiful right triangle right here. Okay, so this here will be the coordinate x, and if we go over this way, this will be the coordinate y. So this physical distance from the center to this x-coordinate, from here to here, this is a length of x, and the length from here to here, this length will be y. So what we can do here to find a relationship between x, y, and this radius here, I hope you see, is the Pythagorean theorem. So the Pythagorean theorem says that the square of the hypotenuse, which is r here, will be equal to the sum of the square of the legs, which will be equal to x squared plus y squared. So here we have it. This is the formula that describes a circle of radius r that has a center at 0, 0. We have a formula for it. Okay, I'm going to go ahead and erase this right here. And hopefully this formula shouldn't be too surprising, that really wherever we are on this circle here, we can always draw this right triangle, and it'd always be true that we'll have, the hypotenuse of r, one of the legs will be y, and one of the legs will be x's. So it would always be true that r squared will be equal to x squared plus y squared, the equation of a circle. Okay. So we have the equation of a circle of radius r with center 0, 0 is going to be x squared plus y squared is equal to r squared. Okay, let's just do kind of a quick exercise here. So, exercise. What is the radius of the following circles? Okay, let's say our first one is we have, let's say, x squared plus y squared is equal to 9. Or how about we have one that's x squared plus y squared is equal to 7. Go ahead and pause the video and try to think about what the radius of these two circles will be. Okay, let's do it. Well, for this first one here, if we're kind of matching everything, what we see here is that this 9 is the same thing as the radius being squared. So this is telling us that the radius squared is being equal to 9. So we could solve for r by square rooting both sides. So plus or minus the square root of 9. Or r could be plus or minus 3. In this case here, we're thinking about the radius being a positive distance. So we're not going to care about the negative. We'll actually only care about the positive. So this is telling us that the radius must be 3. Okay. Similarly, for this one here, this is saying that the radius squared is equal to 7. And again, we could square root both sides. So we'd have the radius for this circle, or this would be a circle of radius root 7. Beautiful. So we just derived the equation of a circle of radius r if its center is at the origin. And really, it was just an application of the Pythagorean theorem. But if we want to be a little bit more general, the center of the circle doesn't have to be at the origin. It could be at an arbitrary location, which we'll call h and k. So let's derive the equation of a circle with radius r and center at h and k. So let's draw the picture. For right now, or at least for the picture, let's assume that h and k are positive, but the exact argument will be the same if we put it in any quadrant. So let's say here's the center of the circle. Let's say this has coordinates h and k. And let's think about a fixed radius, a fixed distance from this point. So all the points that are a fixed distance r from the center h and k. So here is r. Okay. Now let's go ahead and grab a random point. Let's grab a random point on our circle right here. And we'll have a x coordinate of x and a y coordinate of y. Okay, so we just, kind of similar how we did it with the circle with the center at the origin, what we're going to do with this picture is, again, we're going to draw a beautiful right triangle. Okay, so let's mark a few points here. So the center has a x coordinate of h, and the center has a y coordinate of k. Okay. The point on our circle has an x coordinate of x and a y coordinate of y. Okay, so let's think about this physical distance from here to here and the physical distance from here to here. We just want to find the lengths of the legs of this right triangle. Put a little right triangle symbol here. Well, what will this physical distance here be? Well, from the origin to here is a distance x, and from here to here is h, so we want to take x, and we want to remove h, so this distance right here will be x minus h. Similarly, the distance from here to here is y. If we want this physical distance, we want to take y and remove k. So here we'll have y remove k. So now if we use the Pythagorean theorem, the sum of the square of the legs, the x minus h squared plus a y minus k squared will be equal to the square of the hypotenuse, which is r squared. Beautiful. So here we have the general equation of a circle of radius r and centered at h and k. Now, in a way, we could have actually guessed that this is what the formula would be based on function transformations. In the case where h and k is positive, what we're doing is I'm taking this x value and I'm subtracting a value h. Remember, when we subtract something directly from the x value, that's going to shift the graph to the right. So it's not surprising that when I subtracted h from the x coordinate, that shifted our graph right h units. And now in this case, what's a little bit different compared to how we normally do transformations is usually we've never subtracted or added something directly from the y value, but it's going to act exactly how it works with subtracting or adding something from the x value, except it'll just be up and down now. In this case here, when I subtract a positive value k directly from my y value, that's going to shift my graph up k units. In this case here, if actually we were adding, if there was a y plus k, if we add something directly to the y value, that'll actually shift it down k units. So it works very much the same way as with our function transformations. When I add a value, so maybe we'll write this up a little bit in general. Let's write this in general. So we have x minus h squared plus a y minus k squared will be equal to r squared. Well, in this case, let's say if h is positive and if k is positive, okay, well, this is going to shift the circle. This is going to shift the circle to the left, to the right h units. And adding or subtracting a positive k value from y, this is going to shift the graph up k units. Okay. If h was negative, getting a little crammed over here. If h was negative, this would shift the graph to the left h units. So for example, if h was something like -2, this would be an x minus a negative 2 squared, or this would be a x plus 2 squared. Just looking at this piece right here, since we're adding 2 directly to the x value, that's going to shift the graph left by 2 units. So in this case, if h is negative, we're going to shift the graph left h units. Okay. And if k is negative, this will shift the graph down k units. Okay. Let's do an example. Okay. Let's go ahead and let's sketch the graph of the following circle. Okay, so let's say we are given x minus 2 squared plus, how about a y plus 3 quantity squared is equal to 16. Okay, so if we're thinking about the graph, let's say x squared plus y squared is equal to 16. This would be a circle. This is a circle of radius. I hope it's radius square root of 16, radius 4. And right now, it's with center 0, 0. Now let's think about what I've done to the circle here. When we subtract 2 directly from the x value, this is going to shift the circle right 2 units. Okay. Here, we're adding 3 directly to the y value. This is going to shift the graph down 3 units. Shift down 3 units. Okay. So for this circle right here, let me get a better marker. For this circle right here, if we're just trying to write down its key features, this is a circle of radius 4, say r equals 4, and center at 2, negative 3, since it shifted to the right 2 units and down 3 units. Okay, from here we can sketch it. I'm going to erase some of this here. So this has center at 2, negative 3, and it has a radius. Of r equals 4. Okay, so 1, 2, 1, 2, 3. Okay, so here's the center of the circle. Okay, it has a radius of 4, so I guess we could go up 4 units. 1, 2, 3, 4. So here's the point 1. So this will be a point on the circle. Now we need to go left 4 units. So 1, 2, 3, 4. Here's negative 2. This will be another point on that circle. Okay, 1, 2, 3, 4. 2, 3, 4, 5. This will be the point 6. This will be a point on the circle. 1, 2, 3, 4. This will be at negative 7. This will be another point on the circle. While this is not perfect, here we have a picture of that circle. Okay, obviously not perfect, hand drawn, but here's a picture of here's a graph of this circle here. Okay. Let's do another one. Another exercise. Let's find the equation let's say of a circle, let's say with center -1, -4, and radius, let's say 8. Maybe go ahead and pause the video, and I want you to find the equation of this circle. Okay, let's do it. So here we have that the radius is 8, or we could, I guess, start by writing down the general equation of a circle. So x minus h squared plus y minus k squared will be equal to r squared. Okay, well, we have that our radius is equal to 8, and looking at the center here, we can see that our h will be -1, and our k will be -4. So if we input all those values in, this will be an x minus a -1 squared plus a y minus a -4 squared will be equal to, the radius squared will be equal to 8 squared. So this will be a x plus 1 squared plus a y plus 4 squared will be equal to 64. And here we have it. Okay. So this is saying that if we didn't have the plus 1 and the plus 4, we'd have a circle of radius 8, and it would be at the origin. But what did we do to it? Well, since we added 1 to x, we moved it to the left 1 unit. So it's not surprising that its center has a coordinate at -1. And here, since we're adding 4 directly to the y value, that's going to shift the graph down 4 units. So it's not a surprise that its center has a y coordinate of -4. Okay. Let's do another exercise. Okay, let's say we want to find the equation of a circle, let's say with, center -1, 5, and goes through the point let's say goes through the point, how about -5, 2. Go ahead and pause the video and see if you can think about the equation of this circle. Okay, let's go ahead and do it. So in general, we're trying to find something of the form x minus h squared plus y minus k squared is equal to r squared. Well, what's great is we actually already know what the center is. This here is telling us that our h is -1 and that our k is 5. So we'll have a x minus, I guess, a -1 squared plus a y minus 5 squared will be equal to the radius squared. Okay, well, this will just be x plus 1 squared plus a y minus 5 squared will be equal to r squared. Okay, so this is saying we have a circle of radius r. If it was at the origin, what did we do to it? Well, this says we shifted it left 1 unit and up 5 units, so it's not a surprise that its center is at -1, 5. Now, the question is we need to figure out what the radius is. So what will the radius be? Well, I think there are 2 ways we could do this problem. One is you could try to find the distance between these 2 points. So if we draw our picture, okay, so we have the center at what? -1, 5. So here's the center of the circle, and it passes through the point -5, 2. -5, 2. So I know that this, from here to here, this will be the radius of the circle, and if I were to draw it, I'm going to kind of run into this a little bit, but if we were to draw this circle, roughly this is the equation, or this is the circle we're trying to find the equation for. Well, how can we figure out what this radius is? Well, we could use the distance formula. So this is -1, 5, and this is what? -5, 2. Okay, well, let's find the distance between those 2 points. Maybe what we'll do that over here if we use the distance formula. Okay, this is going to say that the distance is going to be the difference between my x coordinates. So how about we do a -5 minus a -1 squared plus a 5 minus 2 squared, all square rooted. Okay, so this is saying that d will be equal to, well, let's see here, what is this going to be? -5 plus 1. So that would be the same thing as what? -4 squared plus a 3 squared. So we'll get our distance is going to be equal to, what does this be? 16 plus 9. So what will that be? 25. So it looks like here that the distance between these 2 points is 5, but that distance will be the same thing as the radius. So maybe I could put an r here. So we have that the radius will be 5. Here, though, we want to plug in the radius squared. So we have that the radius squared will be 25. So putting everything together, we have x plus 1 squared plus a y minus 5 squared will be equal to 25. So here's the equation of this circle. Another way we could have done this problem, instead of kind of resorting to the distance formula, really this equation right here is the distance formula. If we just square rooted both sides, this just is saying, the distance, really we're finding the distance between these 2 points here. That's really exactly what we did right here. What we could have done is we had what? x plus 1, since it was a minus a -1, plus a y minus 5, since k was 5 squared, would be equal to r squared. Well, this point is on the circle. So what we want to know here is what value of r would make this point satisfy this equation. We could just substitute that in for x and y. So we have the -5 here. We have the point -5, so let's plug that in for x. -5 plus 1 squared plus our y is 2. 2 minus 5 squared will be equal to r squared. Okay, well, what do we have here? This is going to be the same thing as -4 squared plus, what is this, a -3 squared will be equal to r squared. Or what is this? It's going to be 16 plus 9 will be equal to r squared. Or we have that 25 will be the same thing as r squared, which is exactly what we found over here. Really, we are doing the same thing. Either way I approach this problem, we're doing exactly the same thing. Really, the equation of a circle is the distance formula, just for a fixed distance. So that's how we can do this problem here. Okay, let's do one more problem. One more problem. Okay. Let's go ahead and find the equation of a circle, let's say, where -1, 3 and 5, 5 are the endpoints of the circle's diameter. If you don't know what a diameter is, the diameter is twice the radius. So let's say here, diameter is equal to 2 times the radius. Okay, maybe go ahead and pause the video and see if you can do this problem on your own. Okay, let's do it. For this problem, it might be helpful to draw a picture. Okay, so let's see here. So we know that these 2 points here are on the circle. So -1 and 3, this is a point on the circle. And also 5 and 5. 5 and 5. So this point here is on the circle. And these are at the end points of the diameter. So the distance from here to here, this is the diameter. And we have a circle. I'll attempt to draw the circle. I don't know, kind of roughly thinking this will be the center of the circle. So this, let's see if we can attempt to draw a good circle. Okay, that's my best attempt. Okay, so here we have this circle, and we have these points as its endpoint. The endpoints of the diameter, 5, 5, and -1, 3. So when we're trying to find the equation of a circle, we really need two different things. We need to know what is the center of the circle, and we also want to know what is its radius. So we want to know center, and we need to know the radius. Okay. Well, let's try to see if we can think about maybe the radius first. Okay. Well, this length here will be the diameter. So from here to here, this is the diameter. Okay, but half of that will be the radius. So we can either find the radius first and then figure out the distance from the center. I'm sorry, we could maybe first figure out the center first and then figure out the distance between the center and one of these 2 points. That might be a good thing to do. Or we could find the length of the diameter using the distance formula, cut that in half. We could then figure out the radius, and then we would still need to figure out the center. Either way, we are going to need to figure out what the center is. So let's try to think about how I can find this location here, which is the center. Well, a good thing to kind of note here, kind of draw these lines here, trying to figure out the x and y coordinates of this one. Well, notice that the x coordinate of this point right here will lie halfway in between these 2 x coordinates here. So the x coordinate of the center will be what's in between these 2 x coordinates. So to figure that out, I guess what our h value will be here. To figure out what's the number in between these 2, well, we could just find the average of those 2 points. So we could do 5 plus -1. So we're going to add them and cut them in half. We're going to find their average. So this should be, what, 4 over 2? Well, we're going to get out 2, which seems reasonable with our picture we have here. So its x-coordinate must be h. And similarly for the y-coordinate, okay, if I kind of draw this line here and this line here, it's reasonable to think that the y-coordinate for the center will live halfway in between these 2 y-coordinates. So to figure out what the k should be, we could take the average of the 2 y-coordinates. So that'll be 5 plus 3 all over 2. So that'll be 8 over 2, which will be 4. So we have our h, we have our k, and they will be, our h will be 2, and our k will be 4, which seems to make sense from our picture. So we have that our center must be at 2 and 4. Awesome. All right, let's kind of start filling in some of the pieces. To find the equation of a circle, we have an x minus h squared plus a y minus k squared is equal to r squared. We're just trying to fill in the h, k's, and r's. Well, we have our h is 2, so we have an x minus 2 squared, and we have our k was 4, so we'll have a y minus 4 squared will be equal to r squared. We just need to figure out what r is. So again, we could just, if you want to use the distance formula to figure out the length of this line here and cut it in half, you could definitely do that. But since I already know what the center is, and I know that this point here must satisfy this equation, what I want to do here is I want to figure out the value of r, which forces, let's say, 5, 5 to be on the circle. So we could just input 5 for x and 5 for y and solve for r. And we actually should get the same answer if we did it with x plugging in -1 for x or y being equal to 3. So let's do that. Okay, let's try plugging in, let's do 5, 5. So if we replace our x with 5, sorry, I'm not blocking too much. So what, 5 minus 2 squared plus our y coordinate will be 5. 5 minus 4 squared will be equal to r squared. Well, what is this going to be? This is going to be 3 squared plus 1 squared will be equal to r squared. Or what will this be? 9 plus 1. So 9 plus 1 will be equal to r squared. Or we have that 10 will be equal to the radius. Or 10 will be equal to the radius squared. I guess r will be equal to the square root of 10. But when I'm plugging into the equation wants the r value squared. So we have that the equation of the circle should be x minus 2 squared plus a y minus 4 squared plus 10, or equals 10. Right. This should be the same as actually if we plugged in -1 and 3. So let's just test that idea out. This should be on the circle. So if we plug in -1 for x, -1 minus 2 squared, plus our y value is 3, so 3 minus 4 squared will be equal to the radius squared. Okay, well, what's this going to be? -1 minus 2, that's a -3 squared. Plus that'll be a -1 squared will be equal to r squared. So here we're going to get 9 plus 1 will be equal to r squared. Or again, that we have our radius squared will be equal to 10. So it worked, didn't matter which of these 2 points you picked. Either way, we get that the equation for this circle here is x minus 2 squared plus y minus 4 squared equals 10. Okay, that's all I have for talking about the circle. In the next video, we'll discover our second conic. We'll see you there. Take care.